Hello everyone, we're going to do another set of notes on electricity. This one's specifically going to be on circuits though. So we got to set up our page. So we draw our line down the side and two across this with our section over here with your name on the top and the date. So it's 4/13/21. So up here on the top, we're going to write circuits. And then our essential question, how do circuits work? All right, so in a circuit, kind of like in any electronic object or device, it's going to need a current or a flow of electrons. So we're going to write electric current. I'm going to underline that. And this is the flow of electric charge. So those are electrons that are moving. So it's similar to water flowing in a pipe. So the unit we're going to use for current is actually an amp, or an ampere. It's still going to be an actual separate word though, a vocab word. Ampere. We're going to abbreviate this as amp though. And that's going to be the flow of electrons. But more specifically, it's basically the electrons per second. We would also abbreviate this as just a capital A. I think that'll be good for now. Let's just go with that. All right, now let's talk about what a circuit actually is. So, an electric circuit. Now, if we just talk about a circuit in general, it's usually like something that goes back on itself, like a racing circuit. You have a start and a finish and they meet at the same point. But this is specifically about electronics. So in this case, it's a closed path that electrons can flow through. Through words. That's an H. Whatever. So it's a closed path. So I'm going to draw a little picture here, and I want you to draw that as well. So draw a little square. It's my battery. I'm going to have a plus and a minus. We have some wires. Put this to a switch. And then I'm going to go to a light bulb. and then back. And we're going to learn in a second that it's going to go from negative to positive. So those electrons are always going to flow that way, from negative into the positive. So let's write that down. So direction of flow is always negative to positive. So negative to positive. Put parentheses. And that's why you always, when you're unhooking a battery, you disconnect this negative one first, because those electrons are moving right away. And if I get rid of this one, those electrons are still trying to go somewhere, and so they end up shooting out the end. So if I were to take this off of a car, for example, and it was running, sparks would fly if I took off the positive before the negative. If I take off the negative, now those have a place to go, into the positive. All right, let's keep going. So we have electric resistance. And this is just how difficult it is for those electrons to flow through an object. We measure that in ohms. And there's a sign that's like that. That's omega. You may have seen that on, I think it's a DC comic thing. But the resistance in insulators, it's much larger than in conductors. All right, so let's go to voltage. So voltage, this is the amount of electrical energy and we're going to measure that in V's for voltage, or volt. So we could have a battery that would be like 1.5 volts, or a 9 volt battery, or 12 volt. And those things, the resistance, the voltage, and the amperage, give us this thing called Ohm's law. And it's a magic triangle. So we have the voltage up top. Remember, we divide if they're above each other, we multiply if they're next to each other. We have the resistance on the bottom. So I would like you to label these. So the resistance, we're going to put ohms. This is voltage. We'll put volts. And this one, which is kind of weird, is our amperage. Which is the current. So it's like the flow of electrons. So the flow, the resistance, and the energy. So there's all of those. So for example, you're going to have to do an example. If I have something that has 0.10 amps and 30 ohms, I would just plug that in. So my amps would go on this bottom one, so 0.1. My 30 ohms would be on the side here. So they're next to each other, so I multiply, and so my answer is 3. Because 0.1 times 30 is 3. Well, what's my label? V for volts. So pretty straightforward. You just plug it in, just like every other one that we've done. And then we'll get into the different kinds of circuits tomorrow. See you guys later.